I will maximize. Yeah, it's my Acer. And I will share the screen. All right, so real quick, crash course, because it's been a week since I've seen you. All right? Chapter 4 is all about decimals. The first thing we learned is just how to read, how to write. Okay? How to read and how to write. I guarantee you that's gonna appear on your test. Okay? Then we learned how to round decimals. Remember, rounding is just the same as it normally is. It's just you need more decimal places now. Okay? Then we learned how to change decimals into a fraction. All right? So to change a decimal into a fraction, read the decimal and word name, and then write the equivalent fraction. If you have to, simplify. You always want to simplify fractions, all right? So that's basically what section 1 and section 2 was. The majority of your test is going to be on everything else. So in 4.3, we learned how to add and subtract decimals. So our goal was to arrange the numbers so that the decimal point is in a column. All your other decimal places should follow suit. Okay? 2, if you wanted to, fill in zeros where you have missing place values. Put little zeros in there. And then 3, just do the operation. Add or subtract. All right? Okay? In section 4, multiplying decimals. So to multiply decimals, what we do is we just multiply first. We don't care about the decimal at all. Just multiply the number. Find the product for me. Once you find the product, then you're going to count the number of decimal places in each of the factors. Add that up. Place the decimal point on the far right side of your product and move it to the left, the same number of decimal places in both numbers. Okay? In section 5, we kind of learned a nice little shortcut. Multiplying and dividing by powers of 10. Now, what do we mean by powers of 10? The powers of 10 that we're talking about are 10, 100, 1,000, 10,000, and so forth. And what we learned was if you were multiplying by a power of 10, then you're going to move the decimal place to the right, the same number of zeros in the factor. And if you're dividing by a power of 10, you're going to move the decimal to the left, the same number of zeros as in the factor of 10. Okay? 4.6, this was, I think, a little bit of the toughy one because it's dividing decimals. So with dividing decimals, you worry about the decimal place first. And remember, you use long division, and your divisor, which is the outside number. Let me zoom out here a little bit. Here we go. Your divisor must be a whole number. If it's not a whole number, you're going to move the decimal place to the right until it is a whole number. You're going to count the number of times you move that. Because in the dividend, you have to move that decimal place to the right the same number of times also. Once you place the decimal, it's downhill. You just divide. That's it. Okay? Now, the key with division sometimes, I don't want to say the key, one of the examples we did with dividing is if we wanted to round to a specific place value. Okay? So remember, to round, you underline the place value and you look to the right. If there's no number to the right, you have to put a number there. So we would put a 0 and then drop it down and keep going until you got to the number of places you needed to round successfully. All right? In section 7, we learned how to change a fraction to a decimal. And it was easy. It was one step. Just divide. That's it. The question becomes, how do you know when to stop? And that was a little bit different. So when we're looking at, let's say, converting 2/3 to a decimal, what we found was if we just kept going, we would have what we call a repeating decimal. Okay? So all we do is we would rewrite the answer so that you put a bar above the repeating part. Okay? Are there any questions there so far? Yes or no? Okay, good. So let me see. I think that's basically it. That's our little crash course. So today, we're going to finish up 4.8. Order of operations and estimating. So real quick, can somebody please refresh my memory on what are the order of operations? What are the order of operations? Oh, yes. I don't like that. You should know that by now. So can you explain what you mean by that? Because I really want to know, do you understand what that means? Can anybody explain it? Like you gotta explain it to me as if I've never seen it before. So Pemdas means absolutely nothing to me right now. I don't know what it means.
PEMDAS is parentheses, exponents, multiplication, division, I think left to right, and subtraction left to right.
What do you mean by left to right? I think was that you, Matt?
Yes.
What do you mean by left to right?
So when you have a problem that has, let's say it has multiplication and division in it, you would do the multiplication first, and if it was the multiplication was on the left side, you would do the multiplication first and then the division second. I think that's accurate. I'm not sure.
Yes, it is accurate. What I'm a little confused with is, did you drink an energy drink before class? Because you rattled that off very quickly.
No, so okay, yes, I did.
Good enough. Yeah, because the way you said it was very fast. It was like listening to a podcast on 1.5 times speed. I liked it. So yes, you're absolutely correct. When we think about the order of operations, all right, we do anything inside parentheses first. We do the exponent second. The key is when we multiply or divide, we do them from left to right in order. Maybe it'd be good if I put the word order. In order of appearance. Meaning, if you see division first, you do that. If you see multiplication first, you do that. And the same applies to addition and subtraction also. So I guess I'm really not teaching you anything new here because we already knew the order of operations. The only thing that's really changing here are just the problems. That's it. Okay? So let's do a couple easy ones first. So we're going to simplify 0.93 minus 0.45 times 0.62. Okay? So remember, parentheses, exponents, multiplication, division from left to right, order they appear. Add or subtract left to right, order they appear. So I have to do this first because I'm multiplying. So what I like to do, and hopefully you're doing this. I'm going to go ahead and multiply these two numbers first. And I just do it off to the right. So remember, when you're multiplying, I don't care about the decimal. I'm just going to multiply first. 5 times 2 is 10. Carry the 1. 2 times 4 is 8, plus 1 more is 9. 2 times 0 is 0, so I know I'm done. Now, I need to start in the tens position. So I put a 0, and I'm going to multiply the 6 now. 6 times 5 is 30. Carry the 3. 6 times 4 is 24, plus 3 more is 27. I'm going to add these two up. 2972. So I know the product is 2,792. Is that correct? Is my math okay so far?
Shouldn't that 2 be a 0?
What do you mean?
'Cause it's like
Oh, yeah. Yeah. Sorry. You're right. All right. So is my math correct so far? Remember, it's been a week since I've seen you.
You have to move the decimal places 4 times.
There you go. Who said that, Alex? Was that you?
Yeah.
Thank you. So now I need to place the decimal. 2 decimal places in the first number, 2 decimal places in the second number, for a total of 4. So I put it on the far right, move it 4 places to the left. 1, 2, 3, and 4. So I have 0.93 minus 0.2790. Okay? So to subtract, remember, add or subtract, you want to align the decimal place. Put zeros where there are no place values, and just go ahead and subtract. So 0 minus 0 is 0. 0 minus 9 I have to borrow. So this turns into a 2. This turns into a 10. 10 minus 9 is 1. 2 minus 7 I have to borrow again. So that turns into an 8. That's a 12. 12 minus 7 is what? 5. And 8 minus 2 is 6 with a decimal point. So 0.6510. Let me ask you this question. The numbers are different. I get that. They're decimals now. They're not fractions. They're not whole numbers like we're used to. Did anything change though with the order of operations from the previous semester or from the previous weeks? Not at all. All right? That's the beauty of math. Once you kind of learn one thing, you can apply it to a lot of different problems. It's just you got to know how to apply it. So I'm going to give you some problems to do now. This one's for you. So we have 86 hundredths divided by 25 hundredths times 3 and 5 hundredths. So go ahead and do that one for me. I would imagine this one is going to take us a little bit of time because you actually have to divide and then multiply. Oh, I just gave the answer away. All right, did anybody get an answer yet? Like I said, this one will probably take a little bit more time.
I got 10 and 492,000.
I like it. Good job. I like it. Let's go ahead. Let's do this now. All right. So when I read this, 0.86 divided by 0.25 times 3.05. I have to do the division first because remember, multiplication and division go left to right in the order they appear. So you got to do the division first. Now, here's the tricky part. With the division, the second number is your divisor. First number is your dividend. And remember, this outside number, your divisor, has to be a whole number before you can divide. Which means I'm going to move 2 places to the right. And since I'm moving the divisor 2 places to the right, I move the dividend 2 places to the right also. So my problem becomes 25 for the divisor, and 86 with a decimal on the right-hand side, and a decimal right above it. So now, how many times does 25 go into 6 or 86? The answer is 3. So that's going to be 75. 6 minus 5 is 1. 8 minus 7 is 1. Put a 0. Drop it down. 25 goes into 110. Or 110, I'm sorry. 4 times. So that's going to be 100. Subtract. 110 minus 100 is 10. Put a 0. Drop it down. And 25 goes into 100 4 times. With the remainder of 0. So 0.86 divided by 0.25 is 3.44. Now, all I have to do is multiply 3.44 times 3.05. So let's go ahead, let's do that. Before I do that, any questions? Am I moving too fast? All right. So I'm going to erase this. I'm going to take 3.44 and multiply it by 3.05. 5 times 4 is 20. Carry the 2. 5 times 4 is 20. Plus 2 more is 2. Carry the 2. 5 times 3 is 15. Plus 2 more is 17. All right. Let me erase my carryovers. Now, if you wanted to, you can multiply 0. And that's exactly what I'm going to do because I like doing things in a very systematic process. So, since that 0 is in the tens position, I start off at the tens. 0 times 4 is 0. 0 times 4 is 0. And 0 times 3 is 0. Now, I'm in the whole number position. All right? So, I need to put 2 zeros. And I'm going to multiply 3. 3 times 4 is 12. Carry the 1. 3 times 4 is 12. Plus 1 more is what? 12 plus 1 is 13. And 3 times 3 is 9. Plus 1 is 10. Just add everything up real quick. 2 decimal places for a total of 4. Put it on the far right side and move it to the left 4 spots. 1, 2, 3, and 4. So you get your total of 10.492. Are there any questions? Yes, no, maybe so. All right. So let's transition a little bit. Let's go into estimating, which is the last part. Estimating, all you got to do is just read it first. That's it. So an example would be something along the lines of estimate the sum by rounding to the nearest hundredth. All right, and here are the numbers. All right. So like I said, you're estimating the sum by rounding to the nearest hundredth. So what we're going to do is we're going to round each number or each decimal to the nearest hundredth and then just add everything up. It's that easy. So remember, when you round, underline the place value, look to the right. So 0.045 estimated turns into 0.05. Plus, underline the hundredth position, look to the right. That's going to be 0.01. And then lastly, for the 0.007, underline a 0, do a line to the right. That's going to round up to 0.01. Now, since you're adding 3 decimals, just align them. For an estimated sum of 0.07. And that's as hard as it gets. Now, sometimes you may be asked just to find an estimated sum. All right? Or how about just an estimation? So, for example, like something like this. Estimate the product. Now, notice I didn't say estimate to the nearest 10th or 100th or 1,000. I just said estimate. In other words, I'm going to leave it up to you on where you think you should estimate. All right? So here are the 2 problems. Oops. Sorry. All right, so what do you think I should do?
Rounded to the nearest hundred.
Why would you pick the nearest hundredth?
Because 0.06 is smaller than 0.004.
Okay, I like that. Well, you said it's smaller. It's not smaller. It's not as precise. Because if you think about it, 0.06 is actually larger than 0.004. All right? Remember how to compare? Let me review that real quick. To compare, you look at the first number. They're both zeros. Move to the right. That's a 6. That's a 0. So 0.06 is definitely larger. But I do like the way you're thinking, Alex. All right? Which is, if we wanted to, we can estimate this product just by kind of looking at what we have and say, all right, well, since I have 0.06, that's to the 100th position. The 0.004, that's to the 1,000th position. So I'm going to round to the nearest 100th just to give me an idea of what this should be. All right, now, here's the problem. If I were to round that, it rounds to basically what? 0, right? Because you underline the place value, you look to the right, that's a 4, so that 0, which is the underlined position, is going to stay the same. So notice you get an answer of 0. Now, you need to ask yourself, does that make sense? What do you think? I'd love to know your thoughts on this. Does it make sense? Would it help you if I told you if it makes sense to me? What do you think, CJ? Would that help you?
Maybe.
I think it makes absolute sense. Would it help you if I spelled the word sense?
Taking a look at it, it does look like it makes sense.
If you think about this in terms of money, this is basically 6 pennies, correct? And if you got 6 pennies in your bank account, you were basically what?
Bro.
You're basically broke. Good word. Which means you have approximately how much money in your bank account? $0. All right? So it absolutely makes some sense to me. Notice it was a play on words there. Sorry, that's my math joke for today. Lame? Was it lame? You could be honest with me. What'd you say, Matt? All right, let's look at another product, okay? We're going to do the same one again. But this time, let's use our brains. Let's think about this for a second. If I wanted to find the actual answer to this, I can multiply it out, correct? But here's what's nice about this. These numbers are very, very small, meaning the 6 and the 4. Matt, what is 6 times 4?
Oh, 24.
Good, 24. How many decimal places here in the first number?
There are 2.
How many in the second number?
There are 3.
So your answer better have how many?
5 decimals.
1, 2, 3, 4, 5. So there's your estimated answer right there. 0.00024, which is extremely close to 0. So at the end of the day, it is up to you sometimes to make an appropriate estimation. All right? The only thing estimates do for us is they give us a really good idea on if we're correct or not. Just because we got an estimation of 0 didn't mean we were incorrect. You got to think about, does the answer make sense? All right, now the sense I'm talking about is this one. Okay? Does it make sense? Is it something that you can sit back and think, oh yeah, I could see that. Okay. Are there any questions? All right. Chapter 4 is done. So like I said, I'm going to upload an exam tonight. It is a test. It will be due Sunday by 11:59 p.m. Okay, so you got all week to work on it. I will not push this exam back for anybody. All right? Now, I'm drawing a line right here. You got all week to work on it. You got all week to email and ask some questions if you need it. Okay? You got Wednesday to ask some questions. Jameson is in a fight right now with 2 dogs, it looks like. Okay? So make sure when you're taking the test, there are no dogs in the room that can fight, because you want to be able to focus. Focus is important. All right, Chapter 5. Chapter 5 is only 3 sections, and it's actually very easy because you already know everything you need to know for this chapter. All right? Chapter 5 is called ratios. In fact, the very first section is called ratio. So this is 5.1, ratio and rate. All right, this is where things get interesting. All right, so let's do some vocab words first, because I'm going to be using these words. We got to know what they mean. First, a ratio is a comparison by division. Okay? So, examples would be something like 3 to 10. Okay? Or 3.10. These 2 little dots mean the same thing. 2. Another way I could have wrote this is 3 over 10. Now, there are some very famous ratios that you have seen in your life. For example, if you've ever rode in a car, there are these things on the side of the road. Here comes my artistic ability. They're called speed limit signs. That's a ratio right there. It's 65 miles per hour. They're telling you that's the maximum speed you're allowed to go, obviously. Now, how do we write that? Is 65 miles per 1 hour. And what that really means, it's a comparison saying that if you traveled at this speed for 1 hour, you would have traveled 65 miles. Okay? Are there any questions with that? So here's the thing that's really happening here. We are now starting to give names to these numbers. Okay, there's a story that's happening here. Okay? We're going to be able to use numbers and these names of the numbers now to solve any type of problem that we really want. All right? But the first thing to understand, a ratio is a comparison by division. Now, I'm going to zoom out here a little bit. These are called unlike measurements, okay? All right, these are called unlike measurements, meaning that they're 2 different ways to describe the numbers. The first number, the numerator, 65 miles. The bottom number is 1 hour, okay? This has a very special name. It's called a unit rate. So when you hear the word rate, you should be thinking change. Something's changing here. Something's happening. All right? And what makes this a unit rate is the fact that the denominator is a number 1. That's what makes it a unit rate. Okay? Now, on the left-hand side, that 3 over 10, I can make this, let's say, 3 feet actually just make it like this. We'll do inches. Okay? This is not a unit rate. This is just called a rate. And what I'm comparing is inches to miles. You would normally see something like this, what I have written here. You would normally see that on like a map in the legend. So I don't know if you remember. Geez, that's a good question. When was the last time you actually looked at a map? Like legit. Like you're like, oh man, I need my map.
You mean like the ones folded up in the car that are like all over the place?
Yeah. Yes. When was the last time you looked at a map?
I have no idea. Maybe 16 years old.
So before there was GPS, we used MapQuest. Does anybody remember MapQuest?
The only app that made you drive into the wrong area and that MapQuest.
I don't know. Here's
MapQuest was awful. That's all I remember about it.
I remember MapQuest, and I used to I used to. Okay, so there's where I live right there. So I remember like typing in like if I wanted to go to PBG Paints Arena. And this is what we had to do. Is it even going to search it? Is MapQuest even a thing? Oh, well, I don't care anymore. I'm over it. So MapQuest, what you had to do is you typed in where you wanted to go, and then you can print up step-by-step instructions on the directions. And we were like, oh my God, this is amazing. Because before that, it was just a map, and you literally had to map out where you wanted to go. And this rate that we're looking at in the legend of the map, it probably would have been written like this, which meant that as you were measuring all the roads and all from point A to point B, if you went 3 inches, that means you will travel 10 miles. I don't think anybody's ever done that under the age of 18. Like, I legit get out my phone and it's maps. I just say, hey, let's go here. And it's Siri, and she takes me there. And I love it. So you would see, we're talking about this rate here, all right, on a map. Now, there's one more definition I want to go over, and it looks like something like this. I'm actually going to show you, I'll just show you a problem. So this is a building. And I have no idea. This is the letter X, by the way. I have no idea how tall the building is. Okay? But what I do know is the shadow that the building casts is approximately 100 feet. All right? Here's me. I'm right here. I'm 6 foot tall. And my shadow is 10 feet. All right? What I can do is I can actually figure out how tall that building is with the information I have in front of me. Okay? All right? Now, these measurements here are called like measurements. And the reason is they're both feet. So if they both match, they're called like measurements. And that's a good thing because it actually helps us when we solve problems. Now, we're going to solve this problem in a little bit, but not right now. But we will. Okay? I know this is really dorky, but I use this all the time. Because sometimes when I'm out with my nephews, they ask me the stupid question, hey, Uncle John, how tall is that building? Or how tall is that tree? They're always interested in stuff like that. I don't know why. And I'm like, why don't we figure it out? So I do it real quick and I tell them that's how tall it is. And they say, I don't believe you. And I say, well, you don't have to. You're going to learn this when you get older. And then you'll sit there and go, boy, that Uncle John was pretty smart. Or they'll just forget about it. What do you think, Robert?
That's a good question.
All right, so now let's start writing rates. So we're going to learn how to write ratios and rates. All right, so here's our first one. Write the ratio of the length of a room to its width if the room is 30 feet by 24 feet. Okay? All right. So they want us to write a ratio. We know a ratio can be written one of three ways. Doesn't matter which way you pick. Traditionally, I use the fraction way. All right? I know that my ratio is going to be a comparison of two different quantities. The first one is the length. The second is the width. So the ratio I'm looking for is length to width. Okay? Now, by doing this, I know the length is going to be 30 feet. The width is going to be 24 feet. And just like all fractions, I want to simplify. And there's our final answer. So my ratio is going to be, and I wrote it in all three ways. You could literally write out 5:4. Or 5 with the colon 4. Or 5/4, 5 divided by 4, which I prefer the fraction way because we're always dealing with fractions anyways. Okay, are there any questions there? All right, so how about this one? I'll be doing this one on May 1st. Now, the reason why I bring this up is my mom, her birthday is coming up. And I'm going to have her over my house for dinner for her birthday. And my uncle, and my two uncles. We'll have just us, that's it. Now, I need to order some food. So, here's just an example problem. What is the ratio of 14 slices of pizza to 12 people? Well, first I write out the ratio. Okay. And now I'm going to go ahead and simplify, which I can simplify this if I wanted to. So, let's see, they're both even. So I know I can divide by 2. And my ratio is 7 slices of pizza to 6 people. Now, something happened between this problem and the previous problem. Can anybody tell me what it is? Can anybody tell me what it is?
The old one was like feet to feet, but this one's like pizza to people.
Exactly. So, if you look at the previous problem, notice that it was feet to feet. My final answer was 5 to 4, and that's because the feet, if you think about it, the feet reduce. Okay? In the second situation, these are two completely different quantities. One is slices of pizza, and the other is people. So if your quantities, if your units of measurement are different, you have to include them in the answer. Okay? That way I know what you're talking about. Are there any questions here? How are we looking? All right. So here's a nice little example for the next one. This is one we are always concerned with when buying a car. This ideology though is changing quickly, and it's because of electric cars. So here's the next one. And also pay attention to the words. Write the unit ratio for a car that gets, or how about this, that traveled 585 miles on 18 gallons of gas. Okay? Now, like I said, this ideology is starting to change here. Because a lot of us, we're always concerned with what's the miles per gallon for your car. Oh, how many MPGs do you get? You know? And I don't know about you. I want my car to get pretty good mileage. Pretty good miles per gallon. What do you think? Anybody here like gas guzzlers? No?
Muscle cars are the way to go.
What'd you say, Matt?
Muscle cars are the way to go. Burning fuel and going fast.
You know what? Where was I yesterday? We were driving back from Molly's parents' house. And a guy pulled up next to me in a Chevy SS Impala. And it was beautiful. I mean, it had the big fat tires in the back, the loud engine with the I don't know, Edelbrock exhaust. I'm not a car person. I don't know these names. But it was really, really pretty. And I bet you he got probably 10 miles per gallon. And here I am on my little Volkswagen. I get like 40. All right? But think about what I'm saying here. I'm saying 40 miles per gallon. That's 40 miles per 1 gallon. That is, remember, a unit rate or unit ratio. What I'm asking you to do in this problem is the same exact thing. I'm saying, let's write the unit ratio for a car that traveled 585 miles on 18 gallons. Miles per gallon. Okay? So my ratio is going to be 585 miles per 18 gallons. And that's the ratio. I want the unit ratio. Okay, I want the unit ratio, which means I want a 1 in that denominator. How do I do that? How do I do that?
You could divide.
I could if I wanted to. So let's go ahead. Let's divide. So let me write that 8 a little cleaner. So 18 does not go into 5, but 18 goes into 58. How many times? 3? So that's going to be 24 with a 2. Yeah, that's good. So 58 minus 54 is a 4. Drop down to 5. 18 goes into 45 twice. It's going to be 36, so let's see here. I got to borrow. 15 minus 6 is 9. Now, I have to put a decimal point. Drop down to 0. 18 goes into 90 how many times? Let's try 5. 5 times 8 is 40. 5 times 4 is 5 plus 4 more is 9. So this car gets 32.5 or 32.5 miles per 1 gallon. So remember, when we are talking about a ratio, just give me the ratio and simplify. If we are talking about a unit ratio, you're going to have to divide these numbers. You're going to have to give me an actual answer. Now, in this situation, we did divide, but you could have also simplified this fraction and then divided if you wanted to. Okay? Regardless, the key, when you see unit, you need to be thinking a 1 in the denominator. All right, are there any questions there? Okay. Well, 5.1 is done. Like I said, chapter 5 is very small. 5.2. is proportions. Okay? Now, a proportion is nothing more than a ratio equal to another ratio. So, well, I guess that's what we're going to be using it as. Just let me write down the definition first. A proportion is a statement that two ratios are equal. So a ratio equal to another ratio. All right? Now, there's a lot that's happening here. All right? There is a lot. First, if a proportion is a statement that demonstrates that two ratios are equal to each other, then that also implies that the units have to equal the units also. So, for example, if I have dollars per pound, then my other ratio also has to be dollars per pound. That's it. Because they're equal to each other. All right? Now, if we wanted to solve proportion problems, we will use the technique called, and finally we can use this. How many of us have heard of this before? Cross multiply. All right? We could finally use this technique called cross multiplication. Notice I went almost the entire semester without saying that. We went through the entire fractions chapter and we never cross multiplied. Okay? Cross multiplying is very special. You can only cross multiply when you have a proportion. That's it. You can only cross multiply when you have a ratio equal to another ratio, okay?
Mr. Foot,
Yes.
you forgot to put the word use in above.
What do you mean? We will use the technique called cross multiply. What would I do without you, Robert? You keep me honest. So, first thing we're going to do, let's determine if we have proportions. Now remember, a proportion is a true statement that says this ratio is equal to another ratio. So we're going to determine whether or not these proportions are true or false. Okay? Was that my house or was that somebody?
That's mine.
That was weird. That's okay. All right, so here we go. Determine if this proportion is true or false. How do we do that? We cross multiply. So let me show you how that works. Cross multiply is you are going to literally make like a cross, like an X, okay? And you multiply the opposite corners. So I'm going to take 5 times 104 and set that equal to 13 times 40. Now, if 5 times 104 is the same exact answer as 13 times 40, then this is a true proportion. Otherwise, it's false. Okay, so 104 times 5, let me go ahead and write that out. We get 20, carry the 2. That's going to be 0 plus 2 more is 2. So we get 520. Now, let's go ahead and do 13 times 40. Four times 3 is 12, carry the 1. 4 times 1 is 4, plus 1 more is 5. So because the left and the right sides equal each other, this is true. Okay? All right, next one. How about this one? I gave you one that works. Let me give you one that fails. How about 4/12 equals 5/9? Well, like I said, all you would do is cross multiply. 4 times 9. 12 times 5. 4 times 9 is 36. 12 times 5 is 60. 36 does not equal 60. So you would just write false. Okay? Are there any questions? All right, so earlier I drew a picture. I said we had this building. It was X feet. But it cast a shadow that was 100 feet long. I also drew myself standing at 6 feet, which is a complete lie. I'm only 5'10". But I want to keep it whole numbers. So I do what most men do. We'll round up our height. All right? Jameson, why are you laughing? That wasn't supposed to be funny.
I just think it's funny because I'm like 4'10". So
Are you really?
Yeah.
My mom is 5 foot exactly. And every year for her birthday, I pick her up over my head. So I'm going to do it again this year. Viviana, why are you looking at me like that? I just grab her and I'm like, roar, and I just press her up over my head. All right, so I'm 6 foot, but I cast a 10-foot shadow. And I told you we're going to solve this problem. Here's what I know. I know that I can create a ratio. And the ratios are very simple here. All right? The ratio for the building is going to be x feet over, so let me write it like this: x feet height over 100 feet shadow. Now, earlier I said proportions are true statements. And if we have two ratios that are equal, then that means their units have to be equal as well. So that means the ratio for me is going to be 6 feet height over 10 feet shadow. All right, so what I did is I just created two little ratios. But here's the most important part. My units on each of them are the exact same in the same positions. If that's the case, then what you can do is you can create a proportion. And you can solve for x. Now, how would we solve for x here? Cross multiply. Because I have a ratio equal to another ratio. Does that make sense, everyone? All right. So if you wanted to, you could cross multiply. If you wanted to, that's 6 over 10. You can reduce that. I'm going to do it both ways. Let's just cross multiply first. So I get 10x equals 6 times 100. I always write it out first. That will make so much more sense when you are in MAT080. For now, just write it. So now I get 10x equals 600. Now from here, we have to solve this. Now we went over how to solve this type of problem a long time ago, but I'm just going to remind you, all right, that when you have 10x equals 60, you're going to divide both sides by 10. In other words, on the left-hand side, you're going to read that as 10 times x. So you're going to divide 10 by both sides. You do the opposite operation. So the opposite of multiplication is division. Now, if you do that, notice the 10 over 10, well, we know from fractions, 10 over 10 is 1. So I'm left over with x equals, and then 60 or 600 divided by 10 is 60 feet. So the height of the building is 60 feet tall. All right. Now, this is a very special setup, okay? All right, that's a special setup. Only because the numbers worked out very nicely. That's not always the case, but it might be. So that is how I tell my nephews how tall something is. I legit have one of them stand still. And I just, with my feet, I just measure their shadow. Because my feet are about a foot big. All right? So I just count off a couple steps. Then we count off how many steps the shadow of the building is. And then I just set this problem up real fast. And I tell them, building's about 60 feet, buddy. Wow. They have no idea the magnitude of the number 60 feet. They just hear a big number and they just think it's large. All right? So, I'm going to give you a couple proportions just to solve. That's it. I just want you to solve. Then we're going to move into the last section in this chapter, which are all word problems. Okay? So here's what I just want you to solve some easy ones. So go ahead and do those two problems, please. Okay, we ready? I think the first one's more difficult than the second. I could be wrong, though. All right. So let's go over the first one. We'll go over A. So we have a proportion. X over 5 equals 23 over 10. We're going to cross multiply. So we get 10x equals 5 times 23. Okay. You actually got to figure out what 5 times 23 is. So that's going to be 15, carry the 1, 115. So 10x equals 115. Now, once we get that set up, the number in front of the variable, we always divide both sides by it no matter what. Since we're dividing by a factor of 10, I know the decimal is on the right-hand side, and I'm dividing, so I move it to the left, the same number of zeros in the number 10, which is 1. So x equals 11.5. That was the first one. Now the second problem, I'm going to do something first. Anybody see what I'm going to do first before I do anything? Before I cross multiply, I'm going to do something first. Does anybody see it? Who got an answer for part B?
I got 6.
You got 6? Now, did you just cross multiply right off the start, Alex?
Yeah.
All right, here's what I'm going to do. What did I do?
You simplified.
Yeah, I saw that 2 over 6, and I simplified it. You can always do that. You can always do that. Now, the reason why I did that, Alex, it makes my life a little bit easier when it comes to cross multiplying and then dividing. Because when I cross multiply, I get 1 times 18, but let's be honest, that's just 18. And 3 times c. Then I divide both sides by the number in front of that variable, like always. That gives me c equals 6. So, did you have to simplify? No. Did it make it a little bit easier for me? Yes. All right? It really helps when the numbers get kind of large. If you simplify first, then it really kicks in. All right? Are there any questions or anything? All right, so before we move on, I just want to review a little bit, okay? Because we did a lot already. 5.1. We learned about a ratio. It's a comparison by division, okay? We learned about like units or like measurements and unlike measurements, okay? And then we learned that all unit rates will have a denominator that is a 1, okay? We learned how to write. There are 3 ways to write. You can write 3 to 10 as the words 3 to 10. You could put a colon in between the 3 and a 10, or you can write it as a fraction. Then we learned how to just write a couple ratios, reading it and just figuring it out. The key, anytime you have a ratio, you always want to simplify, okay? If you have like measurements, it will just simplify down into the numbers because those measurements end up canceling each other out, all right? If you have unlike measurements, you got to keep the names in there because I got to know what you're talking about, okay? Any questions so far? All right. If we take two ratios and we set them equal to each other, and as long as the units match, so like I said in this example, pound or money or dollars over pounds has to equal dollars over pounds. If you have that situation where you have two ratios and they're equal to each other, you've just formed what we call a proportion. And how do we solve proportions? Cross multiply. Cross multiply. The first example we looked at, excuse me, was just determining whether or not these proportions are true or false. All you do is cross multiply. The left should equal the right. Then we looked at a very easy problem. It looked a little complicated at first, but it was kind of easy. It was figuring out how tall a building is. And what I really wanted to show you in this problem is that you can create a ratio out of anything. Doesn't matter. You can create a ratio out of anything. The key is when you go to set up a proportion, which has an equal sign, you better make sure that your units match. They got to be the same in the numerator and the denominator. And if they are, then you can go ahead and you can find whatever you need to find just by cross multiplying. Okay? Remember, to cross multiply, you literally just write it out. And then the second step is divide by the number in front of the variable. Okay? 5.3 is just combining 5.1 and 5.2 into word problems. That's it. All right? So 5.3 is just applications. So we'll look at some word problems and we'll call it a day. All right, so the first one. Just give me a second here. I'm going to have to set this up. All right, so a pro shop advertises, golf balls at 6 for $13.75. At this price, what will John, meaning me, what will I pay for 5 dozen golf balls? Now, there's a lot going on in this problem. First things first. We got to figure out our ratio here. Okay? Now, I don't want numbers. What I want are units. Because like I said, we know we're solving using proportions, which means I'm going to have a ratio equal to another ratio. And I know this is going to be a fraction equal to a fraction where the units have to match. So what are my units? What do you think?
It'd be 6 over 13.
Oh, I don't want any numbers yet, Jameson. You got to be careful with numbers. I just want units, but I like the way you're thinking.
golf ball and dollars.
There you go. I like that. That's all I needed to hear. Now notice we have two situations here. We have the situation on the left. That's going to be the pro shop. And then we have the situation on the right. That's going to be John. Okay? If you wanted to, you could create a table. You really could. Okay? So here's like the little table you could create. All right? Number of golf balls, price. We know at the pro shop. Now this is where you have to be careful. Because at the pro shop, you get 6 golf balls for $13.75. Does 6 golf balls make up a dozen? What do you think, CJ?
No.
Matt? Good, perfect. No. So we need a dozen. How many's in a dozen?
12.
Good. So if I just added this again, 6 more golf balls. All I have to do is just add those two prices together. 5 plus 5 is 0. Carry the 1. That's going to be 14.5. Carry the 1. So in the pro shop, for 12 golf balls, they're going to charge me $27.50. Okay, so that's the pro shop. What does John want? How many golf balls do I want?
5 dozen.
Yeah, 5 dozen. That means 5 times 12. So that's 60 golf balls. What I want to know is, what will John pay? So notice we created a little table, or if you want, you can go directly into the ratio. It just really helps if you write the units first. No numbers, right, Jameson? No numbers. Just write the units first. So for the pro shop, 12 over 27.50 equals, for John, 60 over X. Now it's just a matter of cross multiplying, dividing by the number in front of the variable, and just telling me how much am I going to pay. So the word problem, the hardest part is just setting it up, which is always the hardest part with word problems. I get that. So I kind of showed you two different ways. You can go directly into the proportion, but the key to that is making sure that you do the units first. Or you can always create a little table. But once again, you just got to organize it. So let's go ahead, let's solve this problem. So we cross multiply. 12x equals 60 times 27.5. Now I'm going to cheat a little bit here, only because, we're kind of pressed for time. 60 times 27.50. So 12x equals 1650. And then I divide both sides by the number in front of the variable. To give me $137.50. So that's how much I'm going to pay. Are there any questions? Yes or no? All right, I'm going to give you one to do then before we leave. Let's see here. What's a good one? Here you go. We'll do this one because this one was just in the news. A 12.8 ounce box of Cinnamon Toast Crunch contains 1,430 calories. How many calories are in 1.2 or in a 1.2 ounce serving? Did anybody happen to see this in the news?
I saw it on Facebook.
Yeah, I guess like somebody. Oh, I forgot I have my calculator still up. Sorry. I think I think it was like somebody famous. I don't know, but I think they found like shrimp tails, when they poured out some Cinnamon Toast Crunch. That's why I picked the problem. Because
What I read, they found shrimp tails, but then the company said that that's just sugar. So the guy actually had it sent out to like get tested to see what it was.
And was it just sugar?
I don't know. I didn't end up seeing it.
Oh, I hope it was just sugar. Because then if I was the company, I would tweet out, "In your face."
Yeah. So.
All right. So go ahead, do that problem for me. Hey, you okay? You good? You take a little nap? If you decided to use a table, I went ahead and kind of set it up to see if that helped you a little bit. Oh, bless you. All right, anybody get an answer yet? How many calories are in 1.2 servings?
I got 134.06 calories.
Anybody else get around 134 calories?
I did.
Okay, all right, so let's do this. All right. Let's see here. If I use the table, case 1, well, that's just going to be what the box is telling me. So they're telling me in 12.8 ounces, 1,430 calories. What I want to know is, if I have a 1.2 ounce serving, how many calories is that going to be? Okay? So my proportion is going to look like this. Now, like I said, I don't care how you set this up. The only thing that matters are units equal units. So 12.8 ounces over 1,430 calories. That has to equal 1.2 ounces over X calories. Okay? Now, if you wanted to, you could have done this. You could have flipped them. You still get the same exact answer. And here's how you know this. When you go to cross multiply, you're going to get 12.8x equals 1430 times 1.2. If you flip them, you still get the same exact setup. It doesn't matter. What matters? Units equal units. Okay? How are we looking so far? Pretty good? All right. So for simplicity, I'm just going to pull this out. So 1430 times 1.2. So you get 12.8x equals 1,716. And then divide both sides by 12.8. So x is going to give you 134.06, rounded to 2 decimal places. That's fine. Calories. All right. I cannot stress this enough. What we've just learned today, ratios, proportions, and how to solve them, you can use this every single day in your life. All you got to do, set up units equal units. And you can make anything a ratio. You can. Number of pets per animal. I mean, I know it's a stupid ratio. Number of pets per animal. So, if I give each cat 15 pets, how many pets would I need to pet 10 cats? Set it up and tell me. Doesn't matter. Ratios are everywhere. How to solve them is easy. Where students always make their mistakes are setting up the units. Remember, units equal units. Okay? Are we good? We'll call it a day.